So I'm Aaron King. I have this company called Aon Biomarkers. And basically, what I wanted to know was, first of all, what changes with age? Because nobody has that list yet. So I wanted everything that changes with age, kind of start digging deeper. And that has led to this core philosophy. So the philosophy is that aging is anything that changes with age. And aging happens to everyone. So then we're trying to answer, okay, well, what changes with age? And it seems fairly obvious once you look at scatter plots like this. The gray dots are individual data points. The red and the black, the red is average and the black is median. And you can see that they're calculated based upon the year of age. So these are like kind of like floating point measurements. And then there's some medical ranges in the background. But more importantly, you can see that LDL cholesterol on the left is got this arc to it. And HDL cholesterol on the right is basically the same from when you're born to when you die. And on a population level, it doesn't seem to change. So the left one, LDL, is changing with age, and on the right one, HDL is not. Does it change for everyone? And this is a point, and I'm sure that there's some people who are going to have questions about this, but so when the black and the red dots are overlapping, that means that the median and the mean are both changing at the same rate. So on the right-hand side is forced exhalation volume, and that changes with age pretty reliably. On the left is plasma fasting glucose, and you can see that the red and the black have pulled away from each other. That indicates a pathogenic subpopulation. It means that some people, it's changing for some people, but not everybody, and that we don't really know whether that's changing on a whole species level or not. Now, why does aging change for everyone? Because there's a point to be made about personalized healthcare and the diversity of human populace, but every single person in here drinks water, and every single person in here has a head, and there are pieces of biology that just are non-negotiable. Our skin color might be all different, but we do have skin. So there are pieces where it's like, hey, look, I've never met a person that doesn't age. That means there's something intrinsic about life that the vast plurality of human experience, nobody just doesn't age. And so it's gotta be something that affects everyone. If we're looking for things on a population level that affect everyone, that's what we're gonna find. Okay, so this is cool. This on top is visceral fat mass, and on the bottom is plasma fasting glucose. And what I did here, this is all NHANES data, I'm paring down, so I'm removing data points from the top graph, and this bottom graph is the same pool of people, and it's changing. So you can see that it used to change with age, and as you remove everyone with high visceral fat, you also see that plasma fasting glucose does not change with age anymore. This does not demonstrate causality, it's simply an association. It says that something is related between these two. So there's a line between these two biomarkers. If we look at the same situation for LDL cholesterol and blood pressure, diastolic blood pressure. So diastolic blood pressure is on the bottom, LDL cholesterol is on the top. If you remove everyone with high LDL cholesterol from the equation, your diastolic blood pressure, or at the population level of diastolic blood pressure, does not change. That curve stays the same. So it's just completely random. There's no association between these biomarkers. So there is no connection there. And if you do this a couple of thousand times, you get this network diagram of biomarkers, which I can say, okay, here's the orange ones change with age, the blue ones don't change with age. The green is an example of a node biomarker. So what I did here was I set alpha tocopherol to a range of 800 to 1500, and I figured out, okay, well, which other biomarkers get solved by only including those people? And then there's a sort of clustering there. But the idea is find linchpin biomarkers that when you set them to the right range, these other biomarkers around them also get solved. And then you can find out which ones are kind of more important, which ones are like so the nodes of the system, and then which ones are peripheral. Okay, switching tracks a little bit. When we look at this diagram, there are separate states. So there's a development period of change. Then for some biomarkers, there's a maintenance period, and then there's a senescence period, where there's just it kind of goes off and then you die at the end. Not all biomarkers look like this. Some of them have less stages, but I haven't seen any with more stages. So the maintenance period is a period of time where there's like basically no change. And I define health span as the time between birth and the end of maintenance. And that's slightly different between than what the normal definition is. The normal definition is at the time that that line crosses into the threshold of pathology, when you're declared diseased, that's the end of health span. For me, I'm defining it as the end of when the biomarker stops like that once it exits maintenance phase. So that's what I just said. And then, so what we're looking here at is inflection points, right? So as some very intelligent people have said before, aging doesn't like happen just slowly over the entirety of your life all the time. There are places where there's critical junctions, and it's different for every single different like biomarker or biomarker systems. The body's kind of like a car where you have like an electrical system or an AC system or the engine. And so groups of things will have inflection points that kind of all sort of collide together. So they show different patterns, and every single one of these different patterns tells kind of a different story about why and how these things are changing. This is just one example, so which is pretty interesting. It's a pretty simple one too. This is PFA toxins in the body. This is an environmental toxin. And on the left, you see male accumulation. So it sort of slowly accumulates. Again, red and black. The black is median, and then the red is the average. So this is accumulating for a vast majority of the population. And then in females, you'll notice that there's no accumulation up until about age 50 or 55, right? And so it's like, okay, well, menopause is at that age. All right, why is this happening? And the answer was fairly obvious. Women who are premenopausal have periods. So they're constantly ejecting material from their body. This is the best way I could put it. And men don't have periods, and postmenopausal women don't have periods. So the PFAs that are in the blood are accumulating in this fashion. It turns out they did a study on Australian firefighters, and if you can remove, they do plasma donation, PFAs go down, and it's a pretty reliable method of just removing PFA toxins from the body. So for this biomarker, I now know, this is pretty cool, I now know how to make this graph a flat line. And now you do too, because it's just you do a plasma donation or a blood donation, and you can take this biomarker that changes with age and make it stop changing with age. And the idea is, so you find out what's happening over here in this flat portion, and then you want to make it happen over here in the non-flat portion, right? Like, what is going on? Why did certain biomarkers, it's like find out why they're not changing, and then replicate that for the other part. So plasma donation is essentially an artificial period. And this is the first therapy that I'm going to actually do on myself because I think it can actually help me potentially. So I'm going to test myself for PFAs. I got Kevin Perot to, I said I roped him in to help. And then I thought, well, you know, if I'm doing it on myself, maybe other people want to do it as well. This is not an inexpensive procedure, but I'm willing to pay for half of people. If you guys want to try this, then just talk to me and I'll cover like half the cost, but you know, I'll get data out of it hopefully. So that's it for my talk. Hopefully we have questions. Yeah.
Awesome, thank you.
How's the time?
Yeah, we can do a few questions.
Oh, how's the time?
There you go. Well, we're a little bit behind, it doesn't matter. Any questions?
Hi, Aaron, thanks, great talk. Are you aware of any research on the correlation between plasma donation and blood donations, like lifelong and longevity?
Yeah, so the effect on longevity overall is probably not going to be huge. People have been doing blood donations all the time. There are some studies that are pretty good looking. So like there's one that says that there's a 30% mortality reduction for like heavy blood donors, even taking into account the healthy donor effect. That's not necessarily the point here. I think that there will be some effect, but the point is the methodology. We're trying to find biomarkers where we can figure out the core mechanism and then measure the outcome of like, okay, I don't need to live for 20 more years in order to understand whether this thing is working. I just need to measure PFAs before and after And then I can actually find out the rate at which the PFAs are going down. And I can have a sort of a trajectory of like, okay, at some point, I'm going to have it back to 0, assuming that I have high PFAs in the first place. And you can actually tell whether it's working like the day after the therapy is being administered, rather than just sort of doing something and praying that something is happening.
Awesome. Thank you, Aaron. I think we have to go to the next one, unfortunately, but you guys can
Yeah.
definitely talk to him during the workshops, and we'll follow up. And also, I want to say, the visualizations that you produced are beautiful and informative, and I wish that my blood test results looked like that instead of what I usually get, which is terrible.
So all this stuff was generated using an app,
Which used to be online.
It is still online.
Okay.
And it's transitioning into the kind of like the thing that you wanted. Mm-hmm. So it might take like a month or 2, but I can probably make that. So that's hopefully coming out soon. So anyway, yeah.
Thank you.
Share it in the WhatsApp.